Howdy, trigonometry students. Today we're going to go over an intro to the unit circle. Some of you may have had some experience with the unit circle, but we are going to be talking about the unit circle either way a lot this semester. If you've never heard of the unit circle, it is okay because we will be taking this from the top. So, let's talk about the unit circle. What is it? A unit circle is a circle with radius 1. Alright, as given by the equation. Alright, now let's go ahead and take a look at a graph. So, as we know, circle is x squared plus y squared equals the radius squared. Of course, the radius is just 1, so we can leave off that square, but I'm going to leave it on there for right now just for the sake of clarity. Alright, and so there we are, there we have it. That is the equation of the unit circle. Note that not only does it have a radius of 1, but when we look at this graph, it will be centered at 0. So once again, when we look at the unit circle will always have its center at 0. Okay, so let's go ahead and look at some points that are on the unit circle. You know, we're given an x coordinate here, a y coordinate here, an x coordinate here, and a y coordinate here, and we want to fill in the missing points here, here, and here. All right, so what we do is we simply plug the coordinate we're given into the equation for the unit circle, x squared plus y squared equals 1, and use that to determine the y coordinate. So with that said, let's go ahead and get started. Root 2 over 2 is the first x coordinate that we are looking at. So let's go ahead and work through it. So again, we have x squared plus y squared equals 1, the equation of the unit circle. And then we're going to plug in root 2 over 2 into right there. And so we have root 2 over 2 squared plus y squared equals 1. Okay? And now we just work through it. So this turns into 2/4 plus y squared equals 1. 2/4 is merely 1/2. Right? And so then we just subtract 1/2 from both sides, and we get 1/2 on the right. Take the square root of both sides, and we get 1 divided by root 2. Now, it's considered improper form to have a square root in the bottom, so we're going to multiply top and bottom by that square root. So we have here root 2 over root 2, just like this. And when you work that out, you will end up with the square root of 2 divided by 2. Okay. All right, and oh, and don't forget the positive or negative on each of these. Right, because there's going to be 2 coordinates that match that. So we got here positive or negative root 2 over 2. Let's take a look at this on the graph. Alright, so the first thing I'm going to do is I'm going to establish the positive or negative by saying n equals bracket -1, +1. Like so. Okay, so we got 2 elements. So n is either -1 or +1. So that n will be our positive or negative. So let's go ahead and put this point in. We're looking at the point. The x coordinate was the square root of 2 divided by 2. And then the y coordinate that corresponded with us was positive or negative square root of 2 over 2. Right, so those are our 2 points. We have one here, we have one there. Note that they are right on top of each other because they both share the exact same x coordinate. And so we have a nice symmetry here about the x-axis. Alright, so now back to the handout. Now we're going to find what the x-coordinate is when we have a positive square root of 2. So when y equals positive root 2 over 2, what does x equal? So just like before, we're going to go ahead and plug in our coordinate, right? We're looking here. We're going to plug that into the unit circle. X squared plus y squared equals 1. So good so far. Now you might notice that we're solving for x instead of y this time. However, note that the equation we're looking at right here is essentially the same as this equation right here, just a totally different variable. So we can just go ahead and cut to the chase and say that x equals positive or negative root 2 over 2. Okay. So here we've got it. Positive or negative root 2 over 2. Let's look at this on a graph. Alright, so now we've got, before, the point that we had before, like the y coordinate was positive or negative. Now the x coordinate will be positive or negative. There we go. Comma, square root of 2, all over 2. Alright, so note that the 2 points we found are symmetric about the y-axis, right? They have the exact same y-coordinate, but they've got different x-coordinates. So they're right on the same horizontal line in this case. Okay, now we're going to look at what happens when we have an x-coordinate of 1/2. And just like we did before, we're going to plug that into the equation for the unit circle. X squared plus y squared equals 1. And that again is the x-coordinates. We're putting it right there, so you plug it in, and we have 1/2 quantity squared plus y squared equals 1, just like this. And then we just work it through. 1/2 squared is 1/4. Again, plus y squared equals 1. Subtract 1/4. And we get 3/4. Take the square root. And we get positive or negative square root of 3 divided by 2. Alright, so that is our result. Let's put that in the table. Again, positive or negative root 3 over 2. Okay, so again, we had the x-coordinate was 1/2, and now we're going to say positive or negative square root of 3 all over 2. Again, note that these coordinates are right on top of each other because they share the same x-coordinate. Go ahead and compare that with the other coordinate that we found. Note that this is closer to the or higher up on the circle if it's on top, or further down when you're underneath than the point that we found before. Okay, so now we've got y equals 1/2 instead of x equaling 1/2, and so we're going to plug that in. Again, x squared plus y squared equals 1, and that is going to go right there. Okay, note that this equation is essentially the same as this equation right here, and it just different variable we're solving for, so let's go ahead and cut to the end. And we have that x will equal positive or negative root 3 over 2. So again, positive or negative root 3 over 2. There we go. Alright, so on the graph, now we've got, positive or negative square root of 3 over 2 and 1/2. So it's worth noting that the coordinates here are flipped with the coordinates here, right? And this is kind of an important thing to kind of keep in mind. It'll help organize the unit circle in your mind when you're thinking things through. So note that they share the same y coordinate, so therefore they are on a horizontal line with each other. And let's go ahead and just take a look at all the points that we graphed here. Like so. Looks like these are all the points that we've found. Note that these 3 critical points in the unit circle will be present in each of the quadrant, not shown here, but we'll look at this one right here. These note essentially it's the same thing, but now I've got all the points in all 4 quadrants graphed. But we will be focusing on this first quadrant for right now. But we will be expounding to the rest of the quadrants in the unit circle in quite some detail as the semester progresses. Okay, so these were all the important parts in the first quadrant, and we also got a few important points in other quadrants, and we looked at what all those look like. When we examine all the 4 quadrants, we kind of notice a nice repeating pattern in the graph of the unit circle. So let's go ahead and move forward in our discussion. We're going to go and talk about the circumference of a circle, and we're going to and terminal points. And the terminal point will simply be an arc length, where an arc length being a fraction of the circumference of the circle. So for the unit circle, as we all know that the circumference is 2 pi r. What is the radius? The radius is 1. So the circumference is simply 2 times pi. And so we'll always be starting from this point right here. Notice that's the point 1, 0. And then travailing across. So you go all the way across. You'll end up right there. So here, our terminal length of the terminal point is simply 2 pi. Note that if the terminal length was 0, the terminal point would still be 1, 0. Alright, so let's take a look at this guy right here. What happens if we only take half, right? Half of the circumference. 1/2 of the circumference, well, that's going to be 1/2 of 2 pi, which is simply pi. And so if the circumference represents going around the circle once, then going around the circle half, we'll go from here to right there. And what's the coordinates there? It's -1 and 0. Okay, and with the arc length of t simply being pi. Alright, so that should make some sense. Let's go ahead and look at, well, what about 1/4 of the circumference? Well, that's going to be 1/4 of 2 pi, which is going to be pi divided by 2. So again, starting here, travailing 1/4 of a rotation will get us to pi over 2. And what are the coordinates there? Well, they are 0 and 1. The x coordinate is 0, the y coordinate is 1. Okay. Now what about 3/4 of the circumference? Well, that's 3/4 of the way around the circle. And so we have 3/4 of 2 pi, which is going to be 3 pi divided by 2. And so now we go around 3/4 of a full rotation around the circle. That puts us right there. And what's the terminal point right there? Well, that's going to be an x-coordinate of 0 and a y-coordinate of -1. Alright? So there it is. Circumference and terminal points. These were all inside of one full rotation around the circle, one full circuit, if you will. Let's look at some instances where we're not only going beyond one full rotation, but we're going to look at instances where we go in the opposite direction, because we've always been going counterclockwise. Well, what happens when we go counterclockwise? We'll note that that's what that negative means. That means we're going to be going counterclockwise. Note this is beyond 2 pi. That means we're going to be going more than one way around. Okay, so let's go ahead and take a look at this. 5 pi. So we want to look at, okay, how many times around are we going? How many 2 pi's can we pull out? Well, it turns out that we can break this into 4 pi plus pi, right? And so that, and we further break it down like this. Now, what does this mean? 2 pi represents one full time around the circle. How many times do we go around the circle? Twice, and then we go an extra halfway around. That's what that means. So on the circle, basically we are going all the way around again, and then we go 1/2 a rotation. Where does that leave us? That leaves us right there. So what is the terminal point? The terminal point is -1 and 0. And there we go. That's the terminal point. Alright, so next one. -pi. What does that mean? That means pi by itself, that is halfway around the circle. But it's negative, so we're going in the clockwise direction. So that means we're starting off here and we're going this direction. And what is that, the terminal point, going to be there? Well, it's simply -1, because that would be the x-coordinate, and 0, because again we're being placed, that places us right there. Okay? Alright, now for 5 pi over 2. So first thing we want to do is break this fraction up. We want to have one of them be a full pi times an integer. So what we do is we go, okay, so let's take out one of the half pi's from there, so that we have 4 pi divided by 2 plus pi over 2, right? If you combine these two together, you'll end up with 5 pi over 2. Alright, so now let's go ahead and evaluate that guy there. Well, that's going to be 2 pi plus pi over 2. So what does this 2 pi mean? This means we go around one full rotation. And this pi over 2, what does that mean? That means we go around 1/4 an extra. So let's go ahead and take a look at this. So we go around 2 pi, and then we go an extra bit right here, placing us up in the top point right here. And so that means we have an x-coordinate of 0 and a y-coordinate of +1. Alright? And that's it. That's our answer.